Welcome to the deep dive. Today, we're doing something a bit different, a tailored exploration, really just for you. We're going to be, digging into some really interesting research on how we learn languages, specifically vocabulary.
Right, and we're basing this on a paper from the Educational Psychology Review. It's called Grasping Virtual Objects Benefits Lower Aptitude Learners' Acquisition of Foreign Language Vocabulary. Quite a mouthful, but really fascinating stuff.
It is. So the core question we're tackling for you is, does actually, physically interacting with virtual objects help you learn foreign language words?
And maybe even more importantly, does it help everyone equally? Or does it, depend on your natural knack for learning languages, your language aptitude?
Exactly, because the study we're looking at had adult participants, and they tested them beforehand, right? So they had some people with lower aptitude, some with higher.
That's right. And they were all learning completely new words
Yeah.
in a virtual reality setting.
Which sounds cool already. But they didn't all learn the same way, did they? There were different conditions.
Yes, three distinct ways they set it up. The first was kind of the baseline. They called it audiovisual, or AV. Just see the word written down, hear it spoken. Simple enough.
Okay, standard stuff. See it, hear it.
Then the second condition, audiovisual observation, AVO. Same deal, see it, hear it. But this time they also saw a virtual object pop up that represented the word's meaning.
Ah, so a visual aid, basically, a virtual picture.
Pretty much. And then the third one, this is the interactive bit, audiovisual observation and grasping, AV.
Okay, so AVE, see it, hear it, see the object.
And you actually had to reach out in VR and grasp the virtual object, hold on to it for a bit.
Wow, okay. So a real step up in interaction there. AV, AVO, AVU, AV, got it. And they tested them afterward?
Yep. Used a couple of different tests. Free recall, just trying to remember all the words you can.
Yeah.
And Q to recall, where they give you a prompt like the translation.
Makes sense. So our mission today, for you listening, is to unpack what they found. What does this all mean for how different people, maybe like you, can learn vocabulary more effectively?
Let's start with the big ideas first, the theory behind it all. The paper talks a lot about embodied cognition.
Embodied cognition. Okay, break that down. It sounds important.
It's basically the idea that thinking isn't just happening abstractly in your head. It's connected to your body, your senses, your physical experiences in the world.
How does that tie into learning languages?
Well, think about how you learned your first language. As a baby, right? It's all about touching things, picking stuff up, moving around.
Yeah, grabbing toys, pointing.
Exactly. And you hear the words linked to those actions, those objects, ball, cup. You connect the sound sequence directly to that sensory motor experience, touching it, seeing it, maybe even tasting it.
Right. But when you learn a foreign language later, it's usually different.
Totally different. Often it's just lists of words, maybe flashcards, repetition.
Yeah.
Much more abstract, less physical engagement. You don't usually, grasp the Spanish word silla while learning it means chair.
Good point. You might just see the word pear.
And the research backs this up. One of the very first things kids learn, language-wise, is names for things they can actually interact with physically, things they can reach, touch, manipulate.
So that physical connection seems, fundamental for native language. Does that link stick with us even when we're fluent?
It seems to, yeah. The article mentions studies showing that even understanding words in your native language is tied to those sensory motor routes.
How so?
Well, get this. Some studies show that if you read words related to actions, like kick or grasp, the motor parts of your brain actually light up a bit.
Whoa, even if you're just reading silently.
Exactly, like your brain is kind of simulating the action. And apparently words for tools, things you use your hands for, often cause more motor activation than words for things you don't typically handle.
That's wild. The brain's almost prepping the action just from the word. You mentioned affordance compatibility studies, too.
Yeah, that's related. It's about how seeing a word or an object can sort of prime you for certain actions. Like, you might react faster to the word cup if your hand is already shaped like you're about to grab something.
Interesting. So the word and the potential action are linked.
Deeply linked. It all points towards this idea that our motor system and language are really intertwined.
It makes you wonder about the origins of language itself. Did the article touch on that?
Briefly, yeah. There's a theory that language might have actually evolved from actions, maybe starting with gestures, like grasping, which then became more symbolic, maybe combined with sounds, and eventually led to spoken language as we know it. So interacting with the world physically could be like the bedrock language is built on.
Okay, that's a powerful idea for native languages. But let's contrast that again with learning a foreign language, which, let's be honest, often feels way harder. Why the struggle?
Yeah, that's the big hurdle, isn't it? Native language learning is usually pretty smooth, almost automatic, but second language learning often feels like hitting a wall.
Tell me about it.
And the typical methods we use, like you said, wordless, rote memorization, maybe just looking at pictures, they often don't stick as well. The memory for those words tends to fade faster.
Right. Flashcards burnout is real. But
Yeah.
you mentioned something earlier, an enactment effect, or sensorimotor enrichment.
Yes, that's a key concept here. It basically means that if you involve your body when you're learning something, use gestures, perform actions related to the information, you tend to remember it better than if you just passively saw or heard it.
So moving helps you remember.
In a nutshell, yeah. The action creates a richer memory trace, more connections in the brain, basically, more hooks to hang the memory on.
Okay, so if physical action helps, how does virtual reality fit in? Why use VR for this?
Well, VR offers something pretty unique here. It gives you this really immersive world where you can interact with things, even if they aren't physically there. You get multiple senses involved, sound, sight.
And you can control it yourself, right? Like decide to pick something up.
Exactly. That self-directed interaction is key. Some older VR studies showed manipulating objects helped vocabulary, but sometimes that just meant like clicking a button on a controller.
Not quite the same as actually reaching out.
Not quite. So this study wanted to look specifically at that more natural, self-initiated movement, the reaching and grasping within VR. Does that physical action make the difference?
Right. So let's dive into the study design itself. Who actually took part?
They got 46 German-speaking adults. Importantly, they'd all learned at least 2 foreign languages before, but only after age 12. So they weren't, early bilinguals.
Okay, so they had some language learning experience, but weren't native bilinguals. And you said they divided them based on aptitude.
Yep. They used a standard test, the Alame test, specifically parts, looking at how well people learn new vocabulary and how well they remember sequences of sounds. Based on that, they split them into a low language aptitude group, LLA, and a high language aptitude group, HLA.
LLA and HLA. Got it. What about the words they had to learn? Were they real words?
No, they used artificial words from something called the Vimy language corpus, basically made-up words.
Why use fake words?
To make sure nobody had seen them before, So everyone started from scratch. They paired each fake Vimy word with a real, concrete German word, something you could actually pick up, like cup or hammer.
Okay, so concrete, graspable objects.
Exactly. And they carefully matched the words for things like length, how common the German word was, just to keep it fair. They even had recordings of the Vimy words spoken by an Italian native speaker to make it sound distinctly foreign to the German participants.
And the VR environment, what was that like?
It was pretty sophisticated, a high-res VR cave. Inside, they saw this virtual underwater scene, a coral reef.
Underwater?
Yeah, and the objects, represented as black and white pictures, would sort of dynamically fall onto the reef scene and then fade out.
Black and white pictures. Any reason for that?
They thought color might add another variable, maybe affect memory in ways they didn't want to measure. So black and white kept it focused on the word-object link and the action.
Clever. Okay, so people are in this VR reef seeing and hearing these new Vimy words linked to falling black and white objects. Remind us again quickly of the 3 conditions within that setup.
Sure. Condition 1, AV, audiovisual. Participant sat down, just saw the word written, Vimy in German translation, on a screen, heard the Vimy word, no VR objects.
Okay, baseline.
Condition 2, AVO, audiovisual observation. Now they sit up,
Yeah.
saw and heard the words like before. Plus they saw the black and white object fall into the VR reef. Just watch it, though. No touching.
Got it. Standing and observing the object.
Condition 3, AVOG, audiovisual observation and grasping. Same as AVO, standing, seeing, hearing, watching the object fall. But this time, they were told, reach out, grasp that virtual object as soon as you see it, and hold it until it disappears.
The key difference being that active grasp.
Precisely. That self-initiated physical action, even though it's virtual.
And then came the tests to see what stuck.
Exactly. Those free recall and cued recall tests, checking how well they remember the Vimy words and their German meanings.
All right. The moment of truth. What did they find? What were the big results?
Okay. Finding number 1. Looking at everyone together, both just seeing the objects, AVO, and seeing and grasping them, VOG, were significantly better than just the basic seeing and hearing, AV.
So adding the virtual object, whether you touched it or not, helped everyone learn better on average.
Yeah, that visual link seemed to provide a boost compared to just the words alone. But interestingly, when they compared Just seeing the object AVO versus seeing and grasping it ADOG, across the whole group, there wasn't a significant overall difference.
So grasping didn't give an extra boost to everyone compared to just watching the object.
Not when you averaged everybody together, no. Which leads us to the really juicy part.
Ah, this is where the aptitude comes in, right? This is the bit that's really interesting for you, the listener. What happened when they split the results by LLA and HLA groups?
This is where it gets crystal clear. The grasping action, the avage condition. It provided a significant learning benefit only for the participants with low language aptitude, the LLA group.
Truly, only for the LLA group.
Yes. The high language aptitude learners, the HLA group, they didn't get any significant extra boost from grasping compared to just observing the object in the AVO condition.
Wow. But both groups still did better just seeing the object compared to the baseline, right?
Correct. Both LLA and HLA learners benefited from AVO compared to just AV. But that extra advantage from grasping, that seems specific to the LLA learners.
That's fascinating. The physical acts specifically help those who generally find languages harder. Did they find anything else related to aptitude in these conditions?
They did. They looked at correlations.
Right.
So in the conditions, without grasping the basic AV and the observation AVO, your language aptitude score generally predicted how well you did on the tests. Higher aptitude, better score. Makes sense, right?
Yeah, that sounds logical.
But in the grasping condition, the AV condition, that correlation completely vanished.
Vanished. So high aptitude didn't necessarily mean better scores when grasping was involved.
Exactly. It's like the grasping activity leveled the playing field somehow, or changed the relationship between inherent aptitude and how well people learned in that specific situation.
That is really thought-provoking. It's like grasping bypassed whatever advantage the high aptitude learners usually rely on. Yeah. How did the researchers explain this? What's their theory?
Their interpretation revolves around different memory systems in the brain, specifically declarative memory versus procedural memory.
Okay, declarative and procedural. Remind me.
Sure. Declarative memory is for, like, facts and events, things you consciously recall. Paris is the capital of France. Remembering what you had for breakfast. It's heavily linked to a brain area called the hippocampus. Traditional learning, like memorizing word lists, relies a lot on this.
Right. Conscious facts and procedural.
Procedural memory is more about skills and habits, how to do things. Riding a bike, typing, playing piano. It's often more implicit, less conscious, and it involves different brain areas, motor cortex, basal ganglia, cerebellum.
Ah, the how-to memory.
Exactly. And the researchers think that learning boosted by sensoromotor stuff, like grasping that virtual object, probably engages this procedural memory system more.
So the idea is maybe the high aptitude folks are already really good at using their declarative memory, which works fine for normal learning methods.
That's the hypothesis. They might just naturally excel at that conscious memorization route.
But the lower aptitude learners, maybe they benefit more when learning taps into that procedural skill-based system through the physical action.
Precisely. It might offer them an alternative pathway, one that maybe plays more to different strengths or bypasses difficulties they have with purely declarative learning. The researchers talk about it possibly involving cognitive offloading for the LLA learners.
Cognitive offloading, what's that?
It's the idea that by doing the physical action, the grasping, they might reduce the load on their working memory. The action itself becomes part of the memory encoding process.
Like the movement helps cement the word.
Kind of. It provides another anchor, another type of information linked to the word, maybe freeing up some bandwidth. It fits with theories that see our sensory-motor interactions as a really fundamental, maybe even biologically primary way of processing information.
So the physical act isn't just extra effort, it actually helps organize the information for memory, especially for LLA learners. And what's really striking is that this worked even without actual touch, right? Just virtual grasping.
That's a huge point they make. No haptic feedback, no feeling the object, yet the act of reaching and grasping was beneficial for the LLA group. It suggests you don't always need literal physical contact.
It's the intention, the motor plan itself, that seems to matter.
It really supports that idea, yeah. This notion of grounded cognition, that our thinking is rooted in our body's interactions, real or even simulated, seems to hold up, even without direct touch here.
It definitely broadens the possibilities for VR and learning. Did they mention limitations or where research might go next?
They did. They acknowledged the study focused on concrete nouns, things you can easily grasp. Would it work for abstract words like freedom or justice? That's an open question.
Hard to grasp justice virtually.
Right. And the grasping action here was pretty simple. What about more complex functional interactions in VR? Like actually using a virtual hammer while learning the word hammer. Would that be even better?
More realistic interactions makes sense. Future research needed there.
Definitely. But even with those points, the implications for teaching the pedagogy seem pretty significant, especially as VR gets cheaper and more common.
Absolutely. What are the key takeaways for educators or learners?
Well, it strongly suggests that VR, particularly using interactions like grasping, could be a really powerful tool to help learners who struggle with traditional language learning methods, specifically the lower aptitude folks.
It offers a potential way to personalize learning.
Exactly. Tailoring the method to the learner. It opens doors for designing language programs that leverage these sensorimotor benefits, making learning potentially more effective and maybe even more engaging for those who need that extra support.
Okay, so let's try and boil this down for you, our listener. The absolute core finding seems to be this. Just seeing virtual objects helps, generally. But actively grasping them in VR gives a real significant memory boost, specifically if you're someone who finds language learning a bit more challenging.
That's the nub of it. And the flip side is just as interesting that the high aptitude learners didn't get that same extra kick from grasping.
Yeah, it really hints that different people might genuinely benefit from different learning strategies, doesn't it? A one-size-fits-all approach probably isn't optimal.
Definitely not. It highlights the value of exploring different pathways.
It really does. So, here's a final thought to leave you with. Think about this. These findings on embodied learning in VR, specifically for language, could they apply elsewhere? To other things you're trying to learn, other skills you want to build?
Good question.
Could adding some kind of physical interaction, even a simulated one in VR, or maybe even just gestures in the real world, be a missing piece for you when tackling difficult new material? Whether it's science, history, new software, anything.
It's definitely worth considering how engaging your body, not just your brain, might unlock new ways to learn.
Something to explore for sure. The power of embodied cognition in practice. Thanks for joining us for this deep dive.